Hello learners, in the second part of this program, I will discuss about the texture where the grain size is inhomogeneous. It includes zoning, reaction rims, Rapakavi texture, X solution intergrowth, both perthite and antiperthite textures. First, I will take up zoning. Zoning, systematic pattern of chemical variation within a solid solution mineral. I am citing an example of feldspar. Feldspar commonly contains two end members, albite and anorthite. Albite and anorthite, they are present in the form of a solid solution. The change in the chemical pattern of the albite or anorthite rings as a result of chemical change, you may be able to see the rings of albite, rings of anorthite alternately. As a result, systematic zoning is formed. As I said earlier, end members albite and anorthite, enrichment of one end member, at the same time depletion of another end member. Best example is plagioclase, where zones are alternately enriched, depleted in anorthite end members. Anorthite is the first formed crystallized mineral, later on albite rings are alternately replaced by albite. Zoning is basically of two types: oscillatory zoning, compositional zoning. Oscillatory zoning is again categorized into two major types, such as reverse and normal zoning. Reverse zoning is also seen in some of the rocks, where the cooling process is again reversed by incorporation of another batch of melt. As a result, reverse oscillatory zoning is also formed. Compositional zoning from core to rim, sectorial zoning or hourglass structure, discontinuities between core and rim is also seen here. I am showing you another slide here. This is also from the lava flow, which display sectoral zoning or hourglass structure. What is hourglass structure? Four colorless and light brown, these are the colorless and these are the light brown pleochroic sectors. These are the pleochroic sectors. Second one is irregular growth surface result in a patchy zoning. This is a patchy zoning. See my cursor carefully, this dotted line, white dotted line covering the black portion is showing the patchy zoning. When you rotate the stage, this becomes gray and this becomes black. It is ascribed to the process where different sectors are much richer in Si and poor in Al. Si means silicon and poorer in aluminum and titanium than 100 sectors. This is the implication. Constitutional supercooling and relative diffusions rate of cationic spaces in the melt and growth rates. This is a second possible reason for the formation of irregular growth surfaces here. Oscillatory and crypto oscillatory zoning with the sectoral difference in the optical behavior. Oscillatory and crypto oscillatory zoning is also because of the difference in the optical behavior. When you rotate the stage, you may find this crystal behaves differentially, optically differentially while rotating the stage. And last implication is relatively fast crystal growth. This kind of patchy zoning is attributed to the fast crystal growth. These are the regions. If you find such kind of features in any unknown rock, these are the four important regions, they may contribute to the formation of this rock. Now, I am citing an example of discontinuities between the zoning. See this dotted line, white dotted line, this shows discontinuities between the zoning, the two types, two zoning. Entire crystal is, the field of view is covered by a large crystal of CPX. CPX is better call it as clinopyroxene, and most common clinopyroxene is agate. White dotted line showing represents zoning of the central part of the agate, this central part here in this portion, and zoning in its exterior part. This indicates magmatic corrosion and regrowth followed interruption in the regrowth. So, these are the regions attributed to the formation of such kind of discontinuities within the clinopyroxene crystals. I am coming to another variety of texture, reaction rims. What do they represent? They represent discontinuous reaction relationship between two crystals. In fractionating magmas are recorded in a reaction rim that surrounds an anhedral partially reabsorbed grain of anhedral mineral. So, when they show discontinuous reaction relationship between two mineral grains, we call it as reaction pairs. Magmatic texture in which more stable mineral surrounds an earlier formed less stable mineral that was not completely reabsorbed in a reaction relation. The rim and rimmed mineral constitute reaction pair, mineral which formed at the expense of the other. See carefully, in a reaction relationship with stably coexisting melt. You might be aware about of the bounce reaction series. Bounce reaction series, again if you see the left hand side you have discontinuous reaction series and the right hand side you have continuous reaction series. So, olivine pyroxene they belong to the discontinuous reaction series of the bounce reaction series. So, such kind of textures they are resulted from the crystallization between the two reaction pairs, and those reaction pairs must have discontinuous reaction relationship. They must have to belong to the discontinuous reaction series. I am citing another example of leucite cyanide. It is a variety of cyanide. Euhedral leucite is replaced by secondary calcite. See here, this is a leucite crystal. Normally leucite is not euhedral, but here it is a euhedral leucite, and this leucite crystal is replaced by this very colorful calcite crystal here. This colorful calcite crystal shows high order polarization colors here and surrounded by secondary reaction rim. It is surrounded by secondary reaction rim. This is a secondary reaction rim. See here, a thin ring like structure is surrounding this crystal of muscovite. The secondary reaction rims are darker than the primary reaction rim. They are light in color, but these reaction rims are darker in color, are indicative of greater amount of volatile at later stage. What does it indicate? When you have a very well developed reaction rim, that means the magma was enriched with volatiles, and these volatiles they are held responsible for the formation of reaction rims. These volatiles reacted with the margins of the crystals. As a result, margins of the crystals they have replacement. Replacement, molecule by molecule, atom by atom replacement has taken place here. As a result, reaction rim is formed. I am citing another variety of texture which is called Rapa-Kivi texture. It is a magmatic texture. Example is Rapa-Kivi granite. Rapa-Kivi texture found in granite, therefore, we call it as Rapa-Kivi granite. We use Rapa-Kivi texture as a prefix here to define a rock. Rapa-Kivi granite shows feldspars. These are the feldspars, rounded feldspars. These are the rounded feldspar grains without plagioclase rims, and typical orthoclase feldspar with darker plagioclase rims. Some of the orthoclase they have darker plagioclase rims. These are the darker plagioclase rims here. As a result, you get formation of Rapa-Kivi texture. how this Rapa-Kivi texture looks under the microscope. It shows Rapa-Kivi texture. Here Sanidine is a high temperature feldspar, rich alkali feldspar surrounded by polysynthetically twinned. This, see here, these strips of polysynthetically twinned oligoclase. Oligoclase is again a variety of plagioclase. So, these feldspars were produced by mixing of sanidine bearing rhyolite magma with basaltic andesite magma. So, if you find such kind of texture, what does it indicate? It indicates mixing of two types of magma. I am showing you a different type of texture here, which is due to X solution intergrowth. What is X solution intergrowth? X solution intergrowth is the process of releasing excess volatiles from an oversaturated melt. X solution intergrowth is attributed to the release of excess of volatile from an oversaturated melt, and as a result sudden dumping of cations is taking place and X solution intergrowth has taken place. I am citing an example of pyroxenes, magnetite ulvolospinel solid solutions and alkali feldspar. When crystallized in slowly cooled magma as a homogeneous minerals from the melt exalt at subsolidus temperatures. See carefully, when the magma contains excess amount of volatiles and it crystallizes under subsolidus temperature, the X solution phenomena takes place. As a result, stable coexisting crystalline phases are formed. X solution texture is represented or commonly known as perthitic texture. The rock is called perthite, an intergrowth of Na and K rich alkali feldspar by unmixing below alkali feldspar solvus. And this scanning electron microphotograph showing A means this photograph shows cube shape, this is a cube shape magnetite crystal, triangular shape magnetite crystal, again in B photograph triangular magnetite crystal. C, this is prismatic magnetite crystals, and D, elongated chain like anhedral grains, is like a bead like structure and it is in the form of a elongated chain like anhedral grains. All the grains are anhedral magnetite grains, or sometimes they are reniform. Reniform means they are similar to the kidney shape. They are kidney shaped grains, they are present there of magnetite. All these varieties, cube shape, triangular, prismatic, reniform, chain like, all varieties of grains, they can be seen or they are formed by X solution between magnetite and ilmenite. Here in this slide, this magnetite, remember this is in X solution with the ulvospinel, ilmenite and hematite minerals. Now, I am coming to another variety of texture which is called perthites and antiperthite or perthitic or antiperthitic textures. What is perthites and antiperthite? Perthites, they are mixtures of two alkali feldspars where host, always the most abundant phase, we call it as host, is relatively orthoclase rich, OR means orthoclase rich, and guest is relatively albite rich, is termed as perthite. When you have a host of orthoclase and guest mineral is albite, we call it as perthite. This is a normal situation, but in certain cases situation is reversed when the host is albite rich and guest is orthoclase rich. Such alkali feldspars are called antiperthite. See, in this thin section, this photograph, this is directly taken from the microscope and it represents complete solid solution and orthoclase albite eutectic system. Orthoclase and albite, they are in the eutectic relationship. Normally albite and orthoclase they are in a solid solution, but here they are in the eutectic relationship. With solvus, it involves separation of two solid phases from a homogeneous solid solution. Two solid phases, that means this is the perthite here, these two perthites they are exsolved from the other mineral phases caused by difference in the size. These are exsolved because of the difference in the size. What is seen here? Feature is more or less same, but what is the difference? The feldspar is myrmecatized. The legend SiO4 legend is detached from the cations and it is present here in the form of a vermicular quartz which shows myrmecatic texture. So, again difference in the size of K ions, K means potassium ions, their ionic radii is 1.59 angstrom, whereas sodium cations they have ionic radii of 1.24 angstrom. So, their ionic size is not much difference in their ionic radii. So, they can be replaced, Na can replace potassium, potassium can replace sodium, vice versa. This replacement is possible. As a result, orthoclase and this alkali feldspar here, the K feldspar rich or see here the orthoclase feldspar here, both of them the Na ions they can be replaced by K ions. As a result, you get perthitic texture, but this perthitic texture is because of the reason that the cation Na and K have more or less similar ionic radii. If there is a vast difference in ionic radii, such kind of replacement will not take place and you may not get a perthite or antiperthitic textures here. What is antiperthitization of plagioclase by microcline? Here you have a plagioclase crystal. This large plagioclase crystal, it shows lamellar twinning, and this M written here, this is because of antiperthitization. Antiperthitization is again alteration of plagioclase is taking place. This irregular zone, again in this area, this here you see again plagioclase crystal is there, but in between this you have a gray color M. This is an antiperthite. Antiperthite means you have a different host here. So, this shows antiperthitic relationship here. Learners, let us summarize what we have learnt in this program. So, we have learnt about zoning, reaction rims, Rappa-Kivi texture, X solution intergrowth, both perthite and antiperthite textures. Thank you very much.